Hello everyone, and I welcome you all to our DS series. And in this video, we are going to start a new topic. We are going to learn about a new data structure called stack. All right. So, as we discussed before, data structures are basically structures used to store data like arrays and linked lists, which we have already covered. And in this video, we are going to learn about star data structure. All right. So, okay, yeah. So a stack data structure is basically a linear data structure which follows the LIFO order. All right. So you might be wondering what is LIFO. So LIFO means last in, first out. All right. Cool. So, stack is basically a linear data structure that follows the leaf order, which is last in, first out. All right. So, what does this exact basically means is suppose this is my stack data structure container, and suppose there is data here like 0, 5, 10, 15. All right, four data. And the container from this side is closed. All right, closed. And you can only insert elements from here. All right. So what we did here is we basically inserted 0 first, then 5, then 10, then 15. And suppose here I insert 20 as well. All right. So every number that is inserted is inserting at the top. All right. So that means 0 was the first number which we inserted, then 5, then 10, then 15, then 20. All right. So consider this as a stack of plates which you see in canteens. Like this is plate 1, this is plate 2, this is plate 3, this is plate 4, this is plate 5. So we know that plate 5 is the last plate which was in kept here. All right. And if you go and if you want to pick a plate, you'll by common sense you'll pick the plate number 5, this one. You're not going to pick this plate, you're not going to pick this plate, you're going to pick the top plate. All right. Because is that what basically common sense is, right? So what does that mean? The last in, that means the fifth plate was kept in the last, was taken out first. Okay. I'll again repeat what I said. The fifth plate was kept in last and is the first one to be taken out. All right. So the same thing goes with our data. So basically this is our container, right? And here we can insert elements. So 20 is the last element which was inserted. And if I have to remove any element from this stack here, so how can I do that? Uh, Only I can remove the top element because the bottom is closed, so I cannot do anything from here. So I can only remove the top element. Yeah, that's correct. Okay, cool. So that's what we mean by last in and first out. Okay, great. Now, there are like some functions, basic operations, which we do on stack. They are basically push, pop, top is empty. So push function inserts an element on the top of the stack. All right. Pop function removes the element which is on the top of the stack. The top function returns the value of the top element, and is empty tells whether the stack is empty or not. All right. Okay. Let me give you an example. Suppose this is my array. This is my data stack data structure. 5, 10. So how will I create this stack? So let me write a pseudocode so you'll understand like what is happening. We'll implement everything in later, but here I'm just writing a pseudocode. Suppose I made a stack s. All right. So I'll just simply s dot push 10 here. I'll do s dot push 20 here. All right. So this is what I did till now. Okay. That's okay. Okay, cool. Hmm. Now if I want to remove this element 10, what will I write? So I'll write s dot pop. It removes the top element. All right. And now if I write s dot top, what will I get? This one will clearly give me answer as 5 because this is the top element. All right. And okay. And if I write s dot pop again, and then I write s dot empty. Is empty is basically used in Java, and s dot empty is used in C++. All right. So after this pop function, our 5 will also get removed from here, and we'll be left with the empty container. So if I write this function, this will return me true. All right. So this is what we do in stack data structure. All right. Hmm. So I guess that much is clear with you. Cool. Now, let's quickly talk about what would be the time complexities of all these functions. So all these functions time complexity would be O of 1. That means they would take constant time to perform these functions. All right. Okay, cool. Now we'll talk about how to implement a stack. Okay. So we implement stack by two data structures. First is array. All right. And second is linked list. So in the next video, we'll be looking at how to implement a stack using an array. And in the further video, we would be talking about how to implement a stack using linked list. So this was the basic introduction of stack data structure. I hope this would be clear to you, right? And we'll be talking more about stack in the upcoming videos. And thank you for watching this video. See you later.